Welcome to an example in which we are finding all complex fifth roots of negative 124i. And we're supposed to answer below in polar trig form. So for there's going to be 5 roots of the number negative 124i. So the fifth root of negative 124i, it's kind of a strange thing. So we might think, well, if I'm going to take the fifth root of negative 124i, I mean, what times itself 5 times? Because that's what a root does, right? Let's think about roots for a second. You know the square root of 9 is 3. And why is that? There's really a 2 there, did you know? Because we say square root. You know what this is. This is x squared, right? Squared means 2. What's math's word for 3? Cube, right? So square root means a 2 root. So when we say the square root of 9, we mean the 2 root of 9. And the answer is 3. Why? Because 3 times 3 twice is 9. That's what square roots do. And so by the same thinking, what would be the cube root? This is cube root of 8. In other words, what can multiply by itself 3 times and be 8? Just like 3 can multiply by itself 2 times to become 9, the answer would be 2 here, right? Because 2 times 2 times 2, 3 times is 8. 2 times 2 is 4 times 2 is 8. So the cube root of 8 is 2. So you know roots are the opposites of powers, aren't they? They ask the question, what number can multiply by itself and become this thing? So what number, so the cube root of 8 says what number can multiply by itself 3 times to be 8, the 2 can. The square root, the 2 root of 9, says what can multiply by itself twice to become 9, 3, etc. So that's what roots are, just to make sure you're clear on that. So then let's go a little higher. What would be the 4th root, say, of 81? What number times itself 4 times? Let me do that better job there. There we go. 4th root of 81. What number times itself 4 times would be 81? Well, 3 again, right? Because 3 times 3 times 3 times 3 is 81. 3 times 3 is 9, and 9 times 9, 81. So the answer would be 3. Let's keep this going. What would be the 5th root of 32? 5th root. What times itself 5 times would be 32? 2. Because 2 times 2 times 2 times 2 times 2, if you multiply that on your calculator by hand, you'll get 32. So the 5th root of 32 is 2. So in this question, they're asking us for the 5th root of this number, negative 124i. Well, that's pretty strange, isn't it? Now, we can do the 5th root of the 1024. Even the negative 1024. But what about the I? I mean, that's weird, right? What's the 5th? How do you do the 5th root of on your calculator? You go 1024 to the power of 1 divided by 5. It'll be, you might have a power button. It's x to the y or up arrow. Depends on your calculator. Or maybe x to the blank. Kind of depends on your calculator. So however you do it, do 1024 to the 1/5 power. And I'm getting the answer 4. In other words, 4 times itself 5 times is 1024. 4 times 4 times 4 times 4 times 4. Oh, and we need to have negative 4. Yeah, I should have, I blew that. It should have been negative 1024 to the 1/5 power. And so that will be negative 4, because negative 4 times itself 5 times is negative 1024. So negative 4 is the root, but then what about the I? What do you do about that? Do you just like throw an I on there and it's all good? Well, no. It turns out it's actually very complex. There's actually going to be 5 different answers. And they're going to involve a negative 4, but there's more to it than that. So I just wanted to give you a big feel about what a tricky and advanced question this is. All of that is just intro. Now let's actually do it. What's the actual method. How do we do it? Well, you go to the notes. The exam 4 notes, I put it right here for you. How do you take the root of a complex number? Well, if the question is rectangular form, then change it to polar form. No, we've already got polar. Oh no, we do. We have rectangular form. Yeah, that's exactly right. We've got rectangular form. So we got to change it to polar form. So that's our first step. Well, how do you change to polar form? See number 7 above. So I'm going to actually put number 7 here. But so changing rectangular form of a complex number to polar form. How do we do it? Plot the point to see which quadrant it is in. Calculate R. Okay. So now one of the parts that might confuse you right away is this number it doesn't have a real part, so you got to put in a 0. 0, make that a little big, minus 1024i. That's our complex number. It is 0 minus 1024i, because 0 is the real part, and negative 1024i is the imaginary part, right? A complex number has a real part and an imaginary part. So you got to put that 0 in there. So you have a real part and an imaginary part. Now, step 1 is you're supposed to graph it. So let's do it. Come down here, and I'm going to graph it on the complex plane. So how do I graph it? Well, the real part is the x. Oops. This is the x and this is the y. So you can't forget this real part. So over 0 down 1024. It goes straight down, doesn't it? This is 0 minus 1024. Remember, this is the real. The x-axis is the real and the y-axis is the imaginary. So starting from the origin, we go over 0 down 1024. Remember how that works? So like if you had, well, yeah, I'm going to leave it at that. So the real part, there's no real part, so we go 0 to the right and straight down. Okay, so that's step 1 is to, oops, right down here, plot the point. See which quadrant is. Calculate R equals the square root of x squared plus y squared. So R equals the square root of x squared plus y squared. R equals the square root of, now what's x and y? Well, this is x, this is y. 0 squared plus minus 1024 squared. Well, that's going to be, this part's just going to go away. It's the square root of minus 1024 squared. If you do that in your calculator, squared, here I'm getting a gigantic number. Put it in here for you. I'm getting 104.8576. 1 million, and then you square root that. Guess what you're going to get? 1024, of course, because the negative became positive because we squared the negative, but then the root and the square just canceled each other out, and it came back to 1024. Do you get it? Right? I squared this number, but then I rooted it, which took it back to 1024. Right? Second powers and roots are opposites of each other. This zero's gone, so we just second powered and then rooted the same number, which those did opposites, right? When I second powered, it got bigger. When I rooted, it went back to where it was. But it's positive because we got rid of the negative sign when we squared. So the R, which is what? The length of the vector, or the length of the complex, the length, how far to the complex number, is 1024. Well, that makes sense. It's straight down 1024. Of course its length is 1024. We should have realized that. That's just the length of the vector. Okay, that's the first step. Oops, right here. Calculate R. Next, find the angle in degrees or radians from the positive x-axis. The reference angle is the inverse tangent of y over x. So let's do that. Okay, so I'm going to come down here and go. So the angle, what here? The reference angle. Inverse tangent, absolute value of y over absolute value of x. It's inverse tangent. Y is this right here, so it's positive though because it's absolute value, over x, which is 0. So do that in your calculator and you'll get air. The minute you try to put this 0, you can't divide by 0. That's infinity. That's in air. That's why your calculator is telling you air, because anything divided by 0 is infinity. Right? 0 goes into 1024 infinite times. That's infinity. So then a lot of students right here freak out. And they're stuck and they don't know what to do. And a lot of them, especially because they didn't do step 1. But we did step 1. Why is that so important? Well, stop for a minute. We don't need tangent inverse. We know what the angle is, right? Here's 0 degrees right here. How far is it to there? Well, that's 270. We know it. The theta, the actual theta, has got to be 270 degrees. I don't need no calculator to tell me what it is. I'm looking at it on the graph. Do you realize that? That's why you have to do step 1, where you graph the number. The complex number is straight down, right? It's over 0 down 1024i. It's straight down. Well, what angle is that? Well, here's 0. So from 0, that's 270 degrees. You know straight down is 270. So you know what the angle is. You don't need the formulas in this case. You don't care that it says air. You just look at it. It's 270, clearly. Okay, so now let's write the polar form. So the polar form is going to be r cosine theta plus I sine theta. That's how you do polar form of any complex number. So it's going to be r, what's r? Or did r here, 1024 times cosine 270 plus I sine 270, right? The angle's 270. By the way, you could double check this. Not needed, not required, but if you look on the unit circle, or just use your calculator, you'll find the cosine of 270 is 0. The sine of 270 is -1. Okay, so what? Well, again, this is not required, but I want to show you, this is 1024 out here, that if you were to distribute this through, 1024 times 0 would be 0, and 1024 times this guy would be minus 1024i. See how it goes right back to our complex number, 0 minus 1024i? It's right. That shows that this is really the polar form of this. They're the same thing. This and this are the same thing. This is just its polar form. And this is the rectangular form, right? Right here. Rectangular form. And this is polar form. Okay, so that is all simply step 1, right? If it's in rectangular form, change to polar form. We did it. Question's now in polar form. Yes, it is. It looks like that. Yes, it does. Find the nth root of r, the front number. Example, the fifth root of this would be that to the 1/5 -3. Okay. So we gotta do that. And so let's come on down here. Fifth root of 1024. What's that? That's 1024 to the power 1 divided by 5. Your power button might be an up arrow. It might be like an x to the y. It might be an x to the blank. It sort of depends on your calculator. Why do we do the 1/5 power? Well, that's what a fifth root means. I don't know if you've learned that from, remember that from earlier algebra classes. But those are the same thing. A fifth root is a 1/5 power. There are two ways of saying the same thing. So that's why we just do the 1/5 power. It's the same thing. It's how you do a root. Okay, let's see what we get here. So you take your calculator, I'm taking mine, 1024 to the power of 1 divided by 5. I'm getting 4. 4. So it's 4. So, okay, great. So we did that step on our calculator. Where are we at? I'm getting lost in my steps. There we go. So find the nth root of r. We did it. Next, find the starting angle, which is theta divided by n, and the difference angle, which is 360 divided by n. Starting angle, theta divided by n, difference angle, 360 divided by n. Okay, let's do that. Come on down. Starting angle, theta divided by n. What's our theta? 270. That's our theta right there, right? See theta? 270. So we're going to take 270 degrees divided by n. What's n? N is 5. N is the root you're doing, right? In this problem right here, we're doing the nth root. So dividing by n, whatever your root, divide by 5, and it gives you, I think it's 54 degrees. Yep, 54 degrees. That's the starting angle, 54. Now, you might wonder, why are we doing that? Well, because that's what a fifth root is, a 1/5 power. So it 1/5 the angles. I'll talk more about the y later. And now we need the, what's it called, the difference angle. The difference angle is 360 degrees divided by n. That's what it says right here in these formulas. Difference angle. So starting angle and difference angle. Both dividing by n. It's theta divided by n and then 360 divided by n. Okay, so that's 360 divided by 5. Remember, n is 5. And so that's 72 degrees. Your calculator will tell you. Okay, so we've got the starting angle and difference angle. Now what do we do? Now, your first angle is the starting angle. The second is the starting angle plus the difference. The third is the last one plus the difference. Keep adding the difference angle to get each new answer staying under 360. Ah, okay. So first angle is the starting angle. That's why it's called starting. The second angle is 54 plus the difference. That's why it's called the difference. It's the difference from angle to angle. That'd be 126. The third angle, remember it's the last angle we got, the 126. Add the difference again. So what's that? 198 degrees. The fourth angle is the last answer we got. Add the difference. That's 270 degrees. The fifth answer, the last one, right? We have 5 of these. Is the last answer 270 plus 72 degrees. 342 degrees. So there's our 5 angles. See what we did? We just did the starting angle, and then every time we just added 72, which is the difference angle. It's the difference from angle to angle. All right, and then we're almost there. Root number 1 is the nth root of r, that 4 we found, times cosine first angle plus I sine first angle. Root 2 is the nth root again, that 4. Cosine second angle, I sine second angle, etc. etc. So let's do it. So the first root is, what was that number in the front? It was 4. Right there. That was the fifth root of 1042. Right, with 4. That has to go in the front. And then it's cosine of the first angle, 54, plus I sine 54. And then the second root. It's going to be 5 of these. Is the same thing. It's just going to be a different angle. Let me just write these out and I'll fill in the angles in a second. Kind of like your answer key does. All right, what are our angles? We just fill them in now. So 54 was the first one, and then 126, and then 198, and then 270, and then 342. There's our 5 roots. There they are. Now, if they want you to stop there, you're good, and that's all they want on this problem. That's exactly what we're going to fill in these blanks right here. So that's all they want. So that's our answer. There we go. Now, I want to spend the rest of this time explaining why. So if you just want the answer, boom, you're done. That's how you do the answer. That's how you use the notes. But if you want to think a little bit more clearly and really understand this, if you're going on in math to higher math, it's good to learn why these things are so. Like, why does this rule work? Let me give you a little logic where this little formula comes from. Let's go back. So this is all the reason why this formula works now. So we talked about roots, right? And so remember the formula we have for multiplying. If I have something like 4 cosine of 30 degrees plus I sine 30 degrees times another one which is 4, let's multiply by the same thing, cosine 30 plus I sine 30. Remember what we learned? Remember that multiply rule? Well, I don't have it in the notes right here, but hopefully you remember. Well, I could grab it. Let me see. I'll go grab the notes real quick to remind you. When you multiply, where is it? There it is. When you multiply there it is, right there, number 8. When you multiply complex numbers, you see what you do there? You multiply the numbers in the front and add the angles, right? So multiply the numbers in the front and add the angles. So let me show you what we're talking about. So you would multiply 4 times 4, in other words, 4 squared. And you would add the angles. So it would be 30 plus 30, in other words, 2 times 30, or 60. Let's just write 60, huh? Okay, so let's think, so what does that mean? Well, that leads us to the power rule. Remember the power rule? If you have 4 cosine 30 degrees plus I sine 30 degrees, and you take the whole thing to the, say, the second power, what did the power rule say? Remember the power rule? That's in the notes right here somewhere, I think. I can't seem to find it. Oh, power rule, oh, power rule. Where are you? Oh, power rule. No, I guess I got to go back to here. So, there it is. Power of a complex number. Here, I'll take a picture of that and move it back over here for you. Power of a complex number. There it is. So how do you do the power of a complex number? Anything to the nth power, you n-power the number in the front, and then you multiply the angles, right? Raise the power in the front to the n and multiply the angles by n. Again, raise the power in the front, multiply the angles. That's how you do powers. So you power the number in the front, 4 squared, and you multiply the angles. Cosine of 2 times 30 plus I sine of 2 times 30. Right? Now, why am I talking about all this? Well, because roots are the opposites of powers. So if you think clearly about this, this is how we do powers. So roots are the opposite, aren't they? Making sense? Am I making any sense right now? So say I want to fifth root. Remember, fifth root of 32. What is it? 2. Because 2 times 2 times 2 times 2 times 2, 5 times is 32. Right? A fifth root asks what times itself 5 times equals 32. That's what a fifth root does. It asks that question. Okay, great, got it. So what? Well, that means when they give us these questions and they say, what's the fifth root of some big complex number like 32 cosine of 100 degrees plus I sine of 100 degrees, we should, how do you find out? A fifth root asks what times itself 5 times equals that number. So what times will that be? 2. So how do we get that? We fifth root the number in the front, don't we? Well, what about the angles? What angle times itself 5 times will be 32? Well, you've got to divide by 5 and divide by 5, don't you? Do you see that? Why? Why? Because, remember when, so this would be it right here, because, put a 2 there, because if you were to multiply this thing by itself, if you were to take this thing here, the whole thing, to the 5th power, it would 5th power that, go back to 32, and it would multiply that by 5, wouldn't it? Right? Didn't we just see that in the multiply rule? So it'd go right back to 100. So rooting is the opposite of powers. So, right? If you power something, it multiplies it. If you power something, it powers the number in the front and multiplies the angles, right? Times. So vice versa, if you root something, a root is just a fractional power. That's what it is. Have you ever thought about that before? That's what a root is. Are you aware of that? A root is a fractional power. So that means 1/5 power. A fifth root is a 1/5 power. That's what it is. It's the opposite. So the opposite of a 5 power is a 1/5 power. So roots are the same as fractional powers, right? A fifth root is a 1/5 power. Okay, so what? Well, then you 1/5 that guy, and then you multiply these guys by 1/5. In other words, you're dividing them by 5. Okay, so all of that is to show why we take this angle in the front and we divide it. That's what the formula says, right? It says you take that starting angle right there and you divide it, you see. Divide it by n. N is the 5, or whatever root you're doing. So that's got to be your answer. You got to take whatever angle here and divide it, because a fifth root is a 1/5 power, and multiplying by 1/5 is the same as dividing by 5. Okay, great. So I see where you get the starting angle, but where'd you get all those other answers? Well, here's the trick on all those other answers. The fact is, if we go back to that, let's go back to this one more time. 32 times the, here, let me do it this way, cosine of 100 degrees plus I sine of 100 degrees. All of that to the 1/5 power, right? So we already talked about how you're going to 1/5 that, and you're going to 1/5 the angles, which divides them by 5. Right, but here's the trick. This we're trying to find all angles for which it'll work. We're saying what angle times, you know, we're going right here, we're saying what new angle times itself, or times 5 will equal 100 degrees, right? When the answer is 20, of course, 20, because you're just dividing that by 5. You're just dividing it by 5, so it's 20. 20 times 5 will go back to 100, right? But that's not the only one. Why not? Well, what if you added 360 here? Now, you realize I can do that because that's the same spot, right? You can always add 360. That's just an extra loop around. You're still at the same place you were at. You're still at 100, really, right? Okay, got it. So what? Why would you want to do that? Well, then you would divide this whole thing by 5, right? So that's the same thing as each of these separately divided by 5. And so that angle's got to work as well. What is that angle? That's 20. And then what's this part? 72. There it is. So you see, 20 plus 72, which is 92, that's got to work also. That times 5 has got to work also. What? Why would that work? Well, try it. Look at that. 92 times 5. What's that? 460 degrees. That's more than 360. Subtract 360. 100 degrees. You see how it goes back? So 92 works. You see the trick there? Do you see how we found that? It's because it's that 360 thing. You can always add 360. And then we're going to divide the whole angle by 5 because it's a 1/5 power, which multiplies by 1/5, which is the same as dividing by 5. So that's where you get what I call the difference angle, right here, where I say the starting angle's theta divided by n, and then there's this difference angle, which is 360 divided by n. Right? 360 divided by n. So the starting angle, theta, here's theta, this is theta divided by n, and this is 360 over n, isn't it? That'll work also. And you can do it again. You can always add another 360. Let me change the color there. You can always add another 360. Right? Because that's the same spot, but then you got to divide the whole thing by 5 because the 1/5 power divides them all by 5. So in other words, that's going to add another 72. So you see how you can keep adding that difference angle? And all of those, let's do one more just to prove it to you. 72 added to 92, the last one we got, just add another 72. What's that? 164. I'm saying 164 times 5 will go back to the same spot as 100. Right? It's another one that'll work. It's another one that'll work. Let's try it. What is 164 times 5? That'd be 20, 32, 420 degrees. Wait, I did not do that right. Am I doing some crazy math here? Having some math challenge. Let's try this again. 5, I'm going to use my calculator. 5 times 164. 164 times 5. There you go. 820. That's better. I don't know what I did. 820. So subtract 360 twice, and you get 100 degrees. You see, it's the same as 100. It's another angle. Another angle. 164 is another angle that times 5 ends up going back to the equivalent of 100. You've got it. So you see how you can just, and how did we get that? We added another 360 divided by 5. Notice we just keep adding that 72. That difference amount, that's where this formula comes from. That's the logic that led them to this formula. You got your starting angle, theta over n, and your difference angle, and you can just keep adding the difference angle every time, and that'll be other angles that multiplied by 5 will go back to the equivalent of the original. So that's how it works. So that's all the theory. You've got the steps. There's our answer.